Today on NerdOut, KES, the hottest of keys. Welcome back to NerdOut, the show where we take a look at Cardano and we break it down, but we don't dumb it down. Today we're talking about KES keys, the hottest of keys. So let's get into it. We're going to learn all about what KES keys are and how they relate to the Cardano network. So what are KES keys? KES keys on Cardano. Cardano stake pools have two sets of keys. Well, three keys, but we're going to talk about two of them today. They have a cold key, which is a standard ED25519 key. And these you want to keep very secure, very private. And then we also have what's called hot keys or KES keys. KES stands for Key Evolving Signatures. And these keys have a self-destruct mechanism built into them, so they only last so long. How this works is the cold key signs the pool's operational certificate, and the operational certificate contains the KES key that is then included in each block. This operational certificate is included every time your pool makes a block. Then the KES key is used to sign the block itself. The KES key is very important, but also it's a hot key, so it's not the end of the world if it's compromised. You can just take your private cold key and sign a new operational certificate with a new KES key and continue the pool's operation. You haven't lost control of the pool if you've lost control of your KES key. You only lose control of the pool if you lose control of your cold key. So what type of KES keys does Cardano use? So there are several flavors of key evolving signatures. If you look at the Cardano spec, it actually has an incorrect bit of information there. Early in the days of the development of Cardano, they were thinking to use these sum 6 or sum 7 KES keys that allowed 2 to the 7th key evolutions. But before the launch of Shelley, they made a call to switch to sum 6 keys. And so the difference is these KES keys can be evolved 2 to the 6th minus 1 times or 63 times. So 2 to the 6th is 64, minus 1 would be 63. And in the Shelley Genesis JSON file, they have actually set the max KES evolutions to 62, I guess to give a little bit of buffer on the 63 before the key self-destructs. But originally in the spec, they were planning to do 90 and 2 to the 7th keys. The reason for this is the block headers are the main thing that's synced to all the pools and all the relays and nodes before the blocks themselves. And they wanted to make those a little bit smaller and get those down under a kilobyte so they could be, I assume, sent in one TCP frame. But that's the main reason for the change, even though if you read the spec, it's not quite up to date. So they'll have to go back and correct that at some point. So let's talk a little bit about the operational certificate. So this is a blob of bytes. It's included in the block header with every block that gets made. So there's a number of things in the block header, like talking about which year the block is made for, versions, signatures, all of that stuff. The operational certificate of the pool that made the block is part of that. And it includes a number of things. The first thing the operational certificate includes is this public key of your KES. And it includes a sequence number. So that's the sequence number of the operational certificate. So every time you generate a new operational certificate, this value must be incremented by exactly 1 during the rotation. Otherwise, the other nodes will not accept this certificate as valid. It also includes the absolute KES period. So each KES period, if you look inside the Shelley Genesis JSON file, it is set to 1.5 days. This value is actually in seconds, but it's easier for me to talk about if I just say days. So every KES period since the start of Shelley ticks this value by 1 every 1.5 days. And we'll talk about that in a little bit. And then finally, we have the cold keys signature of these first 3 bits. So these first 3 bits are just concatenated together, the KES public key, the sequence number, and then the absolute KES period, and then we sign that with the KES cold key, and that's this EB3F, big long number here. And then finally, not included in, well, included but in a different area of the block header is the cold public key, so that we can verify signatures. So let's talk about evolution and rotation. Usually pool operators only talk about rotating their KES keys, but within the KES key itself, there's an evolution. That's why it's called key evolving signatures. And this is kind of the countdown to destruction, the self-destruct mechanism of a KES key. So the KES key evolves over each KES period across the 93 days that a KES is alive for, because we can only evolve it so many times. So each block the pool signs includes this operational certificate. The block is signed with a KES key that has been evolved based on the current KES period. So remember, at the start of Shelley, we start with the very first KES period, and then every 1.5 days, that's just a number that ticks up by 1. So if my opcert, if that was created in the absolute KES period of 689, but the current KES period of the network, it's been more than 1.5 days since I created my opcert. If that is 690, that means my KES key is evolved 1 time before being used to sign the block. So the KES key is actually signing with a different private key every 1.5 days. It switches that up until it runs out of times it can be evolved. If the difference between the network and my KES period is more than 62, that means my opcert has expired and it won't work any longer, because then somebody trying to verify the block can't actually evolve my key enough times to verify the block signature. And so at that point, a new opcert needs to be signed with the current KES period, and then the next block your pool makes, it'll present that new opcert. It'll check that that opcert's increment is only 1 more than the last one the network saw, and then you can continue forward. Now, you could technically get away with never rotating your KES key, switching to a new one, but if you have to put a new opcert out there anyway, you might as well sign a brand new, newly generated KES key just for security purposes. It's silly not to. And then your new KES key can then be evolved 62 times, and that lasts you another 93 days. Now, you can rotate your opcert and KES key more often than that if you choose to. There's nothing that says you can't, as long as it's always incremented by 1. And if you have a very low stake pool, it's important, in, like, maybe you haven't made a block since the last time you rotated your opcert. It's important to put a new KES key on there and a new opcert, but not increment the opcert's counter. Most people will always increment by 1, but there is that edge case if you're just running a very, very tiny, just like a self miner essentially. You may not have made a block in 3 months. So let's talk a little bit about how we verify the block signature. I'm going to apologize right away because this is a little bit small of a screenshot. But we take a look at the signature on that block, and the first thing we do is we figure out this block that's made, what slot is it in, and then we calculate what KES period this block is for. So this is usually in the latest KES period, unless you're validating an old block, like if you're syncing trying to catch up to the tip. But if this is a block that has just arrived, this will be the current KES period. So we know what the current KES period is. Then we look at the opcert KES period, and we make sure that the slot's KES period of the block is greater than or equal to the opcert's KES period. And we make sure that we're also within the max KES evolution. So we make sure it's not too far out in the future, this block that we're just seeing. Once we've done that, we then call verify on this signature, and we have to figure out what KES period the key is rotated to. So we do the subtraction. We take the slot KES period, the one we saw in the block, minus the KES period that was put in the opcert, so we know how many times to rotate this KES key before we do the verification. And that's why we send in this KES period into the verify method to verify the signature. So that's kind of how that works. And I hope you enjoyed this. I hope you enjoyed learning how these self-destruct keys actually work on Cardano. And that's all I've got for you. And with that, nerd out.